Topic 68, example 2, where we solve a system of linear inequalities. Malcolm earns $20 per hour mowing lawns and $10 per hour walking dogs. His goal is to earn at least $200 each week, but he can work a maximum of 20 hours per week. Malcolm must spend at least 5 hours per week walking his neighbor's dog. For how many hours should Malcolm work at each job in order to meet his goals? Alright, so Malcolm's going to have some options here. It doesn't have to be a set number. He's going to kind of have a range or a group of hours that he can work somewhere. So maybe it's 10 hours and 12, or 10 and 12 won't work. But maybe it's 8 and 4 or 9 and 6, whatever it is. It's not going to be one specific point. It's going to be a region where we can work. So a system of linear inequalities is a set of two or more inequalities using the same variable. So the first thing we need to do is we need to define the variables. All right, so step 1, define variables. And we can start with, let's just use x and y. Since we're using a coordinate plane, it'll make a lot of sense. So x we can say is the number of hours spent. So we have two jobs, we're mowing lawns and we're walking dogs. So x would be the number of hours. Let's go with mowing lawns. And then y would be the other job, so the number of hours walking dogs. All right, so those are our two variables. And then using those variables, we can come up with some inequalities. So we know, so let's write inequalities as our second step. All right, so we know that Malcolm is making $20 per hour mowing lawns. So his profit for mowing lawns would be 20 times x, the number of hours that he works there. And then his profit for walking the dogs would be $10. So he would also, we're going to add that 10 times y, because that'll be the amount of money that he makes walking the dogs. He wants to make at least $200 each week. So the profit, this 20x plus 10y, or really let's say this income, this 20x plus 10y has to be greater than 200. But he's also okay with learning at least 200. So 200 is okay. So we're going to say that it's greater than or equal to. So the income has to be greater than or equal to 200. All right, so that covers, so this, let's line up. His goal is to earn at least 200. So that kind of covers that. The next part is he can work a maximum of 20 hours per week. All right, so if we're going to figure that out, well, x is the number of hours that he works mowing lawns. We're going to add the number of hours that he works walking dogs, and that has to be less than 20 hours. But he can work 20 hours, so that's our max. So x plus y has to be less than or equal to 20. All right, and this right here would be the maximum number of hours per week he can work. Now we also have one more piece of information. I'm actually going to change that. I'm going to highlight that in green. Work a maximum of 20 hours per week. And we have one other piece. He must spend at least 5 hours per week walking his neighbor's dogs. All right. Basically, if he doesn't spend 5 hours per week walking his neighbor's dogs, his neighbor's probably not going to hire him, right? He'll hire somebody else. His neighbor's not going to want to hire two different people and have one person do 2 hours and somebody else do 3 hours. So the third equation, we know that the hours walking the dog, the y value, so y value has to be at least 5 hours, so y has to be greater than or equal to 5. Let's fix that 5. And that's even worse. So y is greater than or equal to 5. There we go. So now we have our three inequalities. All right, what you can do next is we want to graph these, and you can use different programs. You can use something like Desmos. You can use a graphing calculator. But when we're doing it by hand or with a graphing calculator, it's important that the y values are isolated. So I need to take this 20x plus 10y is greater than or equal to 200, And if I'm going to enter this in a graphing calculator, I need to have y by itself. And if I want to graph it by hand, it would be much easier if y is isolated. So I'm going to subtract 20x, and I'm left with 10y is greater than or equal to negative 20x plus 200. Divide everything by 10. And now I have an inequality that I can work with. So negative 2x plus 20. All right, so that would be our blue one. So we've just kind of updated that so that we can graph it now. Now we'll take the x plus y is less than or equal to 20. And same thing, although this one's easier, we can just subtract x, and we have y is less than or equal to negative x plus 20. So that one we can now graph in the form it's in. And the y is greater than or equal to 5. That one's fine. We don't have to do anything else with that. So step 3, if you're graphing these by hand, we could say that we need to isolate y. Right. So we can graph. All right, and then from there, our step 4 would be to actually graph them. All right, so we're going to graph. Now, y is greater than or equal to negative 2x plus 20. 20 is my y-intercept, and my slope is negative 2. So I'm going to go down 2 over 1. So that would be down 2 over 1. It's going to be somewhere here, down 2 over 1. So I'm just going to keep drawing little points. So it's kind of tough to see, but I'm plotting little points here. I'm just trying not to make the graph too cluttered. So down 2 over 1, down 2 over 1, and down 2 over 1. So that would be the equation there. We have an x-intercept of 10, which if you know about x and y intercepts and determining them based on your equation, you'll know is accurate. And I'm not going to quite highlight yet, but what we want here is for this one, we're looking for the numbers that are greater than that. So we would shade this way. All right, now you don't want to draw that arrow on a normal graph, but so it doesn't get too cluttered, what I would do is I would be shading to the right of that because I want the numbers that are greater than or equal to. All right, next we're going to do the one in green. So what we have is y is less than or equal to negative x plus 20. So again, we have a y-intercept of 20, but this time my slope is negative 1. So I'm going to go down 1 over 1. So that'll be here, here, and it would just be these points here. It looks something like this, and y-intercept would be at 20. So I'm going to draw my line here. The program do the work for me. There we go. And this one, we want numbers less than, so we'd actually be shading this way. Right, to be shading on the inside or the numbers that are less than. And then finally, we have y is greater than or equal to 5. So that's going to be right at y value of 5. So we'll draw a straight line, a horizontal line there. And we want greater than, so we would shade above that. So I'm going to shade some things, but then I'm going to erase them real quick. So what we're looking for is the shared region. We want to find out what region on this graph fits all of my inequalities. So the blue one is everything over here, okay, because that's on that side. The green one is everything, the green one is everything here. So we'd have that, and we could shade it a little more carefully and things like that. And then the red one would be everything up here. All right, so all of this. And what you'll see is that the area where they all overlap is, let me use a different color, is this area right in here. All right, this is where the region where all 3 inequalities are true. Now, I'm not going to keep it like that, but that's just to give us a quick little sketch. So I'm going to undo all of that, and I'm going to shade inside of there. And what you wind up with is this is the region here. It's not going to be perfect because Using a little marker type highlighter here. It's going to be something like this. All right. And this region is our solution. This is what we were looking for because it satisfies all three inequalities. If I was to pick any point within this region, anything I want, doesn't matter which one, it'll satisfy the blue inequality, the green inequality, and the red inequality. So all of them would work. And what we're looking to do is at any point in that shaded region, you can pick whatever one you want. Again, let's use an example, maybe 10:8. So this point here would work. So I would be allowed, or if not, Malcolm's working. Malcolm would be able to work 10 hours mowing lawns and 8 hours walking dogs, and that would help him make that $200 profit or that $200 income. Any point within this. So I could pick 4:16 could work, right? I could mow lawns for 4 hours and walk dogs for 16 hours. So any of those points within there are going to work, and they're not asking for a specific point. They're just asking how many hours should Malcolm work at each job in order to meet his goals. Well, it depends, right? So anywhere falling in that orange shaded region will do. So our final step, say 5, we would say the solution is the shared shaded region. And that's it. All right, we don't need, oops, didn't mean to do that. We don't want those X's in there. Gotta get rid of those. Well, you get the idea. That X isn't supposed to be there. It is a possible solution, but not the only solution. So the solution is the shared shaded region. And there you go. Try number 2. They're not asking, it's not a word problem. They're giving you all the inequalities. They just want you to come up with the shared region. So you would graph each one and then find out where they overlap. And that is all.